We are where we started to leave off of. Well, that doesn't make sense, whatever. We are back at the devil's calculator, and let's try out this function psi, and we're going to check out what this function does. So 0 psi 0 is still 0, so let's go for 0 psi 1, 0.5. Okay, maybe it's the average. Let's go for 2 psi 2, okay. Let's go for 141 psi 139, 140, yeah, it's the average. So we need to have two numbers that average at 666. Okay, so we can go for 333 psi 999. That one didn't really have any thinking in it, so no need to go too much into detail with this one. Okay, did some basic changes, and just to the setup. Still at level 22, 0 to 0 psi 0 is still 0, 0 psi 3 is 0, 3 psi 0 is 0, okay, 3 psi 3 is 9. Okay, this seems like a basic multiplication, but let's check. Let's go for x, y, x. Now let's go for x, y, and this function shows the commutation or combination, I think. I don't know, but let's just call this the connecting function psi. So we have x, y, we had 0, 0, x psi y was 0, 0, 3, we still had a 0 as an output, 3, 0, we had a 0 as an output, and 3, 3, we had a 9 as an output. So right now we are assuming that we can just have a basic multiplication. Let's try this once more. We're going to go for 3 psi 3 psi 3, and this should go for 27, correct. Last try, 78 psi 3, 437, 34. It seems to be an algebraic thing that just multiplies the two numbers with each other. So what we are going to do is we check 666 and try to divide it into its primes. So 666 is the same as 222 times 3. It's the same as, if you're hearing the bells, that's just outside because it's 7:01 p.m. It's the same as 3 times 3 times, what is 222 divided by 3? Something with 74. And that's the same as 3 times 3 times 2 times the half of 74 is 37, and that should be all. Let's think about this. 37 is non-dividable by 1. Well, it's divisible, not non-dividable by 2, 3, 5, 7, 11, 13, 17. It seems to be alright. Okay, then let's check once more. 9, 18 should fit. So we can't use the 2, and we can't yeah, that's the only number that we can't use. So let's go for, this is the same as 3 times 6 times 37. I just multiplied the 3 and the 2 with each other. Multiplication in real numbers is associative, so you can just put parentheses wherever you want to, as long as you close them. And let's just go for 3 psi 6 psi 37. Let's not call it psi, maybe, because I think the microphone doesn't like that. What number do we want to call that? Gamma? It's not really a fitting number. Phi? No. Also bad. Let's just go for... Let's just go for... I'll think about something, maybe a long way. For now, 0 function 0, maybe f, g. Let's go for g for now. 0g0 is still 0, 0g1 is 1, okay. 0g2 is 4, okay. Let's write that down. 0, 0, 0, 0, 1 is 1, 0, 2, 4, okay. This one is already interesting. Let's go for one more. Maybe it just squares this number. So the assumption that I'm having is 0, 3, if I now type that in, is going to equal 9. It's just a guess. It's not certain whatsoever. Okay, yeah. So this function, the assumption is that the first number doesn't matter for now, and any number we input is going to be squared. X squared, y squared, y squared. Okay, let's try this once more. 6, it should be 36. Okay, and one more bigger number, because we have seen some examples of it not being able to break, but this seems alright. So what about 1G2? It's 5. Okay. What about 2G2? It's 8. Okay. So 1, 2, 5 and 2, 2, 8. The assumption that we now have is x, y is the input, x and y are the inputs, and we get an output of x squared plus y squared. Oh, by the way, I'm using Notepad++ as the writing program here. I thought about using Libre Office, but I'm not that competent with it. Maybe I'm going to use it in one of the next videos, because I like Libre Office. It has a very good spreadsheet function, which I might use that. Anyways, the assumption is this. So let's go for 7G7, 89. That's double the amount of 49. So yeah, it squares the first number and the second number and just it adds it. So let's think about if this is a vector. V equals the components x, y, and then f of our function x. Now it's a function f of basically fxy equals the abstract, I think it's called in English, or the abstract of v squared. Because the abstract of v is, if you look at the Pythagorean theorem, it's x squared. So yeah, x squared the first component, plus b square, y square the second component, and the root of that, the square root of both of this addition. Okay, now we have to think about x squared plus y squared equals 666. So that means that y squared equals x squared, 666 minus x squared. And that means y equals the root of 666 minus x squared. So we need to check for example, what if we just type in 1? Then we have a root of 665. That doesn't work because the root wouldn't be a whole number. I don't know, at least I don't recall there being a good solution for this one. In terms of, I guess we could graph this, because I think that would be the smartest thing. I'm way too lazy. If I do that, that's way too we're going to do this an older way. So so this is going to be, let's think about this, how I want to do this. I'm going to diagraph or do it. I'm going to create a table which is going to have y square, not y but y square, as its output, and the input is going to be x. So we're going to use x as x from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, at least let's go for 25. But for now, I think we are only going to need this much work. Yeah. If I actually have to think about this a little more, then I will do it when the time comes. So y would just be 666, y squared would be 666. This doesn't have a real root, no, not a real root, it doesn't have a whole number root, so we can ignore that one. Let's go for 665, it doesn't have a 625 is 25 squared, 615, No, it doesn't have a whole number root. But this, yeah, okay. 665. Then let's go for this one. We go down 3, so 662. I'm just inputting this one right here. I'm just inputting the x that I have right here into the equation, and then I'm squaring that because I don't want to look at y, because then I would have to write root of 666, root of 665, root, and it's just easier to write it this way. It's not more practical, but it's easier at least. And 662, we need to go down 5 from here, am I correct? Yeah. 657, and we need to go down 7 from here, 650. Let's go to the actual calculator. 25 times 25 is 625, right? So, okay, what is 26 times 26? 676. Not anything. Oh, maybe we would need to go up 10. No, I can't go upwards. Or can I? No, it wouldn't work. There's also another way. Okay, I have an idea. Yeah. Okay. So I have to do this the following way. I'm going to input 25. First of all, clear 25. Then I don't even have to think about this. I think I made this way too complicated. 25 squared equals 625. I do still need 141. So this I could write as 25 plus 16, I guess. And that's just all the numbers that I need. This is 5 squared plus 4 squared. Okay, is this 25 plus, just pretty quick, yeah. So this, then 5, then 4. What? Now I'm confused. Okay, this is interesting. This is quite interesting. So this should output 41. Okay. And if I... Okay. This is interesting. Let's check the... Okay, this function behaves weirdly with using multiple of it. 111, it equals 5. Okay, I think this is associative. Okay, this is annoying. They thought about this. Alright. I thought that it would work in the way that x squared plus y squared plus z squared with the inputs x, y, z. But I guess it would have been a little too easy. Okay, and I do think we have to do the thing that I was talking about right here. At least we're going to do it a little differently. We're going to write down the squares of all the numbers from 1 to 25. 6, 7, 8, 9, 10, 11, 12, 13, 14. You know what? I'm just going to switch over to spreadsheets. I think this is... Okay, we're going to try this. This is a spreadsheet. I'm not the most proficient with spreadsheets, but I think it should be fine. So this is our input. Oh, it's lagging a little bit. Okay, it's back. 0, 1, we're going to do this, and we're going to go up to 25. Let's go for 26. 27. And this one equals this one squared. And we're going to go like this, and perfect. Next, this one input squared. And this one is going to be, we're going to call this one y. We're going to adjust this one just a little bit, and this one is the 666 minus y. So this one we're going to write down equals 666 minus this one. And now we're going to go downwards. Okay. And lastly, this one is going to be the square root of, we're going to call this one z. This is not the programming, I'm just inputting the names of what I want to show you. So I just made a table. This one is the inputs from 0 to 27. This one is the inputs of this is the input squared. This one is 666 minus the input squared. And if this is a whole number, then we can write this one as, right now we are just writing down the equation of y. So this should be the square root equals the square root. I hope that, okay, this works, of this right here. And we're going to drop this down. I actually only need this far. Okay, and we have two solutions. Okay, so we can use the pair 15 and 20. We can use the pair 15 and 21. So 15, 21, and it should work. Yeah. Okay, this is how you can use a spreadsheet in a really cool way. I like that. We're going to keep this spreadsheet going. Well, also do not change anything with that. Okay. Level 24. We're going to go for f of 0, 0. We're going to call it this way. We're going to think of the function as an f of x dot comma y. We're going to think of this as a function on a vector, even though it's more so a function between whatever. We can think of this this way. So 0, 0 works. And we're going to delete all this right here. We're going to go right here, x, y, f of. I think I made something which is a little weird. F of x, y, with the settings of Libre Office. Also, we're going to color those just so that it's a little easier to distinguish those things. Let's go for this. No, not the best color. Let's go for just slightly gray. Okay. This one is going to be a different gray, and this one is going to be the function we're going to go for. No. Let's take our time. We're not in any hurry. This is fine. Okay, now we're going to go like what we did before. We're going to type in a 0, expand to, let's say, 10. In most cases 10 should be enough. This one is a 0, 10 should be enough. And now f of 0, 0 is still 0. F of 0, 1, however, is still 0. F of 1, 0, however, is minus 1. Okay, yeah, I didn't do this in the smartest way. Okay, yeah, we're going to change this. So 0, 0, 0, 0, and now we're going to write in a 1. I think the program should understand what I'm doing. Yeah, okay, it's working. Okay, then we're going to we're going to do a little bit of adjusting, because I want to. This is also a good opportunity for me to learn how to use Libre Office the best way. So let's go for 0, 0, 0, 0, 0. This should be enough. 0, 1, 2, 3, 4. Okay, we're going to go for one more. And now we're going to write in a 1. We're going to expand this one. 4, 5. Like this, and we're going to expand this one. 0, 1, 2, 3, 4, 5, 0, 6. Almost. Now we're just going to copy this one right here, and we can just fill out the rest like this. 4. Somewhere there might be a mistake, but I don't think we ever get to that point. this is mostly universally easy to use, and I think I can just zoom in a little more. I think this is all the space we need. So 0, 0, 0, 1 was also a 0, and yeah, okay, this is not the best way. I have to think about this, how we input this in a better way. But now let's go for 0, 2, we can't, 0, 3 however. 0, 3 is still a 0, okay. The assumption is that all those are a 0. 0, 90 is a 0, okay, yeah. So this one is definitely it might be something with multiplication. Let's go for 1, 1. It's a 0, okay. 1, 3. 1, 3. It's a 2. Okay, yeah, it's the difference of... Is it a difference function? It's definitely weird. So 1, 3 works. Okay, let's go for 1, 4. The assumption would be that it's 3. Okay, yeah. 3, 4. And now we have this. 1, 0 was a -1. Okay, it's annoying. I thought this would work. I'm going to quickly do this off cam. I'm going to just quickly change some things with the table, and then we can continue looking. Okay, I have just made this thing a little smaller. Hopefully it's easier for me to use it. I still have a little bit of a problem with organizing that stuff. -1, 0, 3 was right here. It's still a 3. All this is 0. -1, 1, 1 was a 0. 1, 3 was a 2. Wait a second, 1, 1 was a -1. That's very important. 1, 1 was... No, 1, 1 was a... Okay, my mistake. Alright, yeah. 1, 1 is still a 0. 1, 2 should be a 1. 2, okay, let's go for 5, 4. It's a 15. Interesting. 5, 5 is a 20. I still do not see a... Okay, it seems like a normal line. Okay, we're going to... Maybe we do need to do this once more. Okay. We, first of all, are going to clear all of this. Next, we're going to check out how our function 0 interacts with anything, and interacts by inputting a 0. So this means that our function f of xy is in our assumption something with x times something. At least that's the first idea one could have. But if we write in 1, 0, which we did, well, it would be -1. Or if you write 4, 0, what happens in that case? -4. -4. I don't really understand this. So in this case, it looks like this one looks like y minus x or something. Okay, so x times something if x equals 0 or something. All the things that I'm doing right now are assumptions, so I have no idea what the function is, but I'm trying to find it out. That's the annoying part about this thing. Let's also increase this size. Okay. And I can't press enter because then I would go outside of the space that I have. So I have no idea how you well, it doesn't matter for now. Okay, f of x, y. The assumption is that it's x times something if x equals 0, and it is y minus x if x in equals 0, if y equals 0 maybe, y equals 0. Nah, that doesn't make any sense. So this one is y minus x, it fits. Also, let's check what happens if I input 1 and 4. It equals a 3. If I input 4 and 1, it equals a 0. Okay. Okay, yeah, we can work with that. 1, 4 equals as 3, 4, 1 equals a 0. Let's assume that this is a function, assuming I can't show the graph, but assuming it is a linear function. In that case, it would mean m equals... this is so annoying. Okay. 4 minus 1 divided by 1 minus 4, which would equal minus 1 if I'm correct, minus 3, yeah, minus 1. And if we do this, it looks like minus 1 times x plus b equals y. And that would mean if we have 1, 4, for example, this one would be a 4, this one would be a 1, b minus 1, b equals 5. So the assumption that we could have is f of x equals 5 minus x equals y. On this function we get what? What do we get if we input? That doesn't make any sense. That does not make any sense. Okay. Can I do something with Libre Office where I can plot this thing? Maybe I need more things to work with. I'm going to fill this table out a little more and then think about what I can use. I think I figured it out. So when I filled out the table, I noticed especially this specific part, where here we have the inputs 3 on the x side and the inputs 0 to 3 on the y side. And now if we let our function f, if we let it out on those inputs, then we get this. If you notice this is the basic products, the different products of 3. So this is 3 times minus 1, 3 times 0, 3 times 1, 3 times 2, and the idea is that the y input, this is the second product of 3, so 3 times 2, but we have an input of 3 right here, so we have the idea of f of x comma y is y minus 1 times x. This works for most numbers, most values that I have found. So for now we are going to assume that this is what our function does. And we can now think of 666 as, let's go for 333 times 2, which if we do it like this, we can input 333 and 3, and we should be getting what we want. 333, 3, and we actually got it. So if we input 3 here, y minus 1 would be 2 in that case. 333 times 2 equals 666, so that's how it works. Okay, we are going to go for level 30 today. Are we? I mean, I'm going to do that, but I don't know if I'm going to put it into this part. No, we're going to close this part off right here. I have started using LibreOffice and we are going to continue using it. And like this, I hope you have a nice day. Goodbye, see you in the next video.